This video will be a compilation of all the homework assignments and in-class activities from ISTA 425. It will go in order of homework 1 through 7, and then in the class activities 1 through 13. This assignment is cube speeds. It runs 4 different cubes, all with different speeds based on frame weights. It is meant to show how frame rates can affect objects in games or computer programs. This assignment is vector reflection. The turret, the shooting device, and the reflective surface are controlled by keyboard keys. When you press space, a ball shoots out in the normal vector of the surface. The reflected bullet direction and incoming bullet direction are all calculated and used to reflect the bullet correctly. This assignment is 2D animation. The character on the screen is moving or running, and different sprites that make up the background image are coded in pairs in order to make a continuous background movement. This assignment is called the Dolly Zoom. It is used in many movies, and it is actually a really cool effect to make. The height of the target location stays constant, but the field of view gets wider as the camera zooms in. It looks as though the face is becoming distorted as well, but that is just due to the lighting change. This assignment is called Insertion Sort. In class, we also did bubble sort and quick sort. In the code, if you separate the even and odds to true, it will do an insertion sort, but it will separate the numbers by odds and evens. Insertion sort isn't as effective on big lists as things like quicksort due to big O notation, which you can learn about in ISTA courses. This assignment might look familiar because it is similar to brick breaking. This is a turret at the bottom, and a ball shoots out when you press space. The turret can move, and the C# code will check if the line segment and the bounding circle collision are colliding and destroys the line if it returns true. This assignment is called A-star pathfinding. It is the last assignment in the class and shows an extremely effective method of finding the shortest path. This is cool because it is used in video games for things like finding a way around the map that gets you closer to the endpoint or even the enemy. The final path, the shortest, and the most effective without diagonals is shown in red at the end. This is an in-class activity, and we were supposed to build a pyramid out of cubes using their sizes based on the number of squares needed to build the pyramid. This in-class activity has two parts. One was a game loop which has a square move across the screen, and when pressing U or D, the frame rate increased or decreased. The other part is an angle selector in which you click to move the green and blue lines and have to calculate the angle between them and their position on the screen. For this activity, Hansel and Gretel needed to get home. Help them, we had to help them find a path through all the pebbles they went through without skipping any, as they were the breadcrumbs they left on the way to the forest. The second part is linear interpolation. Depending on the numbers on the sides of the sliding bar, the interpolation value and the percentage the slider is at of the distance between the two numbers changes. This activity was to move a sprite. This might look familiar because it was in the video earlier, but this activity came before the homework, so the background is not moving yet, but the sprite needed to be coded to jump, run, and walk. This activity was meant to help show how to implement 3D graphics. The rocket needed different classes that we coded to move, grow, shrink, and rotate. The next activity we coded was teaching about camera projection. When you hit the 1, 2, 3, or 4, it changes the view, and when you press O, it goes from perspective view to orthographic. You can also check the rotate box, and the camera will rotate around. This in-class activity introduced students to sorting methods. This might also look familiar because earlier there was insertion sort. This, however, is an implementation of bubble sort, which you can also learn about through ISTA courses. Next up, we have an activity about searching. You input a number, and the code should do the search that you click on out of the 4 options on the right. This activity's code shows you how to detect whether or not two objects are colliding. There are different shapes based on the number scene you select, and then the code also allows you to make the shapes bigger and to collide together. next activity has really cool code to implement. You have to put the red and green dots on the radar correctly down at the bottom right, calculate the arrow direction based on the player direction, and turn the target based on the color of the blips, the red and green little pill icons on the screen. If you know the game of life, not the board game, you might recognize this. The objective of the game is to implement the 4 rules of the game of life. It might look like a bunch of random squares, but once you know the rules, it makes implementation really, really fun.